Now let us solve some problems on angle between the surfaces. Find the angle between the surfaces x square plus y square minus z square equals 4 and z equals x square plus y square minus 3 at 2 comma minus 1 comma 2. So here two surfaces are given. We have to find the angle between these two surfaces at the given point. So the two surfaces are, take the first surface as phi 1, so that is x square plus y square minus z square, so minus 4, take it to the left side. Then second surface is phi 2, x square plus y square minus 3 minus z. So we know that angle between two surfaces is cos theta, that is dot product of del phi 1 and del phi 2 divided by mod del phi 1 into mod del phi 2. So we know that del phi 1 is I into del phi 1 by del x plus j into del phi 1 by del y plus k into del phi 1 by del z. So del phi 1 equals I into differentiate phi 1 with respect to x. We get 2x plus j into del phi 1 by del y, 2y plus k into del phi 1 by del z minus 2z. So now we have to find del phi 1 at the point 2 comma minus 1 comma 2. Put x equals 2, y equals minus 1, z equals 2. So del phi 1 is 4i minus 2j minus 4k. So similarly del phi 2 is I into 2x differentiate with respect to x partially plus j into differentiate phi 2 partially with respect to y, we get 2y plus k into differentiate phi 2 partially with respect to z, we get minus 1. So at 2 comma minus 1 comma 2 del phi 2 is 4i minus 2j minus k. So then take modulus for del phi 1. So it is square root of 4 square 16, 2 square minus 2 square 4 minus 4 square 16. So this is equal to square root 36. So mod del phi 1 is 6. So similarly find mod del phi 2. So this is equal to square root of 16 plus 4 plus 1. So this is equal to square root 21. This is not a perfect square, keep it as it is. Now find the dot product of del phi 1 and del phi 2. So that is coefficients of phi 4 into 4, coefficients of j minus 2 into minus 2, coefficients of k minus 4 into minus 1. Then dot product of del phi 1 and del phi 2 is, so after simplifying we get 24. Now cos theta, dot product of del phi 1 and del phi 2, 24 by mod del phi 1 6 mod del phi 2 root 21. So 4 by root 21. So theta is, so cos theta is 24 by 6 into root 21, 4 by root 21. So theta is cos inverse 4 by root 21. So the next problem is find the angle between the normals to the surface xy equals z square at 4 comma 1 comma 2 and 3 comma 3 comma minus 3. So in the previous problem actually we calculated angle between the two surfaces, but here only one surface is given. We have to find angle between the normals to that surface at two different points. So if this is the surface given, so take two different points, draw the tangent and draw the perpendicular line. So here also draw the tangent and draw the perpendicular line. So we have to find the angle between these two normals. So here only one surface is given, we have to find angle between these two normals at two different points. So now given surface is phi equals xy minus z square. So we know del phi equals I into del phi by del x plus j into del phi by del y plus k into del phi by del z. So this gradient is nothing but the normal to the surface. It gives the normal to the surface. So first find del phi 1, sorry del phi, there is only one surface here. Find del phi to the given surface. So I into del phi by del x is y plus j into del phi by del y is x plus k into del phi by del z minus 2z. At first point 4 comma 1 comma 2 del phi 1 is, so for the first point take del phi 1 I plus 4j minus 4k. At 3 comma minus 3 for the second point take del phi 2, that is 3i plus 3j plus 6k. Now find angle between these two normals. So cos theta is dot product of del phi 1 and del phi 2. So we know what is cos theta. So cos theta is del phi 1 into del phi 2 by modulus del phi 1 into modulus del phi 2. So cos theta is dot product of del phi 1 and del phi 2. So coefficients of I 1 and 3, coefficients of j 4 and 3, coefficients of k minus 4 and 6 divided by mod del phi 1. Mod del phi 1 is, so square root of 1 4 square minus 4 square 16 into square root of 3 square 9, 3 square 9, 6 square 36. Now simplify the equation. So 3 plus 12 minus 24 by square root 33 into square root 54. So cos theta is, so minus 9 by square root 3 square root 11. Square root 33 is square root 3 square root 11. So square root 54. 6 nines are 54. So 6 nines are 54 is 3 root 6. So this is equal to minus 3 by 3 into 3. So minus 3 by square root 3 into square root 11 to square root 6. So cos theta is minus root 3 by root 3 by root 3. 3 by root 3 is root 3 square root 11 into square root 6 is root 66. So cos theta is minus, so this becomes root 3 by 66. So root 3 by 66 is square root 1 by 22. So cos theta is minus root 3 by root 66 is minus 1 by root 22. So theta is, so since cos theta is minus 1 by root 22, so the angle theta becomes, when you get negative sign, so theta we have to write pi plus or minus cos inverse 1 by root 22. So this is the angle between the two normals for a given surface at two different points. Now let us solve one more problem. find the values of a and b such that the surfaces ax square minus byz equals a plus 2 into x and 4x square y plus z cube equals 4 cut orthogonally at 1 comma minus 1 comma 2. So here two surfaces are given and it is given that these two surfaces intersects orthogonally at 1 comma minus 1 comma 2. So we have to find the values of a and b. So already we have discussed that if two surfaces intersects orthogonally, then the condition is del phi 1 dot del phi 2 equals 0. So this condition gives that the two surfaces intersects orthogonally. Now using this condition, now we find the values of a and b. So given two surfaces are, take the first surface as phi 1 and second surface as phi 2. So now find del phi 1. So del phi 1 is I into differentiate partially with respect to x, we get I into 2ax minus of a plus 2 plus j into minus bz plus k into minus by. So now at 1 comma minus 1 comma 2 del phi 1 is I into 2a minus a minus 2 minus 2bj plus bk. So by taking x equals 1, y equals minus 1 and z equals 2. So therefore del phi 1 is a minus 2 of I minus 2bj plus bk. So now for the second surface find del phi 2. So del phi 2 is I into 8xy differentiating partially with respect to x plus j into differentiate partially with respect to y 4x square plus k into differentiate partially with respect to z 3z square. Then take 1 comma minus 1 comma 2, putting x equals 1, y equals minus 1, z equals 2. So del phi 2 is I of minus 8 plus j of 4 plus k of 12. So del phi 2 is minus 8i plus 4j plus 12k. So now since two surfaces intersect orthogonally, so the condition is del phi 1 dot del phi 2 equals 0. So take the dot product of del phi 1 and del phi 2, we get coefficients of I minus 8 into a minus 2 plus coefficients of j 4 into minus 2b, coefficients of k 12 into b equals 0. Now simplifying this equation, we get minus 8a plus 16 minus 8b plus 12b equals 0. So minus 8a plus 4b plus 16 equals 0. So taking 4 as common, then simplifying minus 2a plus b plus 4 equals 0. Now since these two curves intersects orthogonally at 1 comma minus 1 comma 2, so this point, given point 1 comma minus 1 comma 2 lies on both these surfaces. So therefore we can write, since 1 comma minus 1 comma 2 cuts two surfaces orthogonally, orthogonally the point 1 comma minus 1 comma 2 lies on both surfaces. So then one comma minus 1 comma 2, so put 1 comma minus 1 comma 2 in equation in the surface 1, so we get ax square minus byz minus of a plus 2x equals 0. This is surface 1. Substitute x equals 1, y equals minus 1, z equals 2. We get a plus 2b minus of a plus 2 equals 0. So simplifying, we get a plus 2b minus a minus 2 equals 0. So a gets cancelled. So 2b equals 2. So b equals 1. So we have got the value of b. Now we have to find the value of a. So to find the value of a, so use this equation. So therefore minus 2a plus b plus 4 equals 0. So minus 2a, b is 1. So minus 2a plus 5 equals 0. So 2a equals 5. So a equals 5 by 2. So a equals 5 by 2, b equals 1.